This is a PSA.
Algae energy is relevant and needs to be implemented into our society so that generations to come have the same great lives that we are living right now, not smog-covered memories and increased energy costs for the non-renewable energies that the general population relies on now. Before we go into algae specifically, we will go through energy via the ocean in general and then algae energy.
So, what can this type of energy and resource be used for?
Oh, I have the answer. The ocean can produce two types of energy, this being thermal energy from the sun's heat and mechanical energy from the tides and the waves. It is used for many applications, but the most popular one is electricity generation. There are three types of electricity conversion systems. Anyways, as I was saying, there are three types of electricity conversion systems. There's the closed cycle, the open cycle, and hybrid systems. Closed cycle systems, these are the ones that use the ocean's warm surface water to vaporize a working fluid. Open cycle systems, these ones utilize surface water warmed by the sun to generate electricity directly into a machine called the evaporator, and then that transforms warm ocean water into low pressure steam. Tests yielded efficiencies up to 97% for this conversion process. And finally, hybrid systems. This type of system combines both closed cycle and open cycle systems. The above are all potential ways that we can deal with water and energy, but for our presentation, we want to focus more on how you can get energy from algae. Algae farms cultivate a new type of algae every few weeks, and algae converts sunlight into energy. Some of the algae store energy in the form of natural oils. Under the right conditions, algae can make a lot of oil that can be converted into biofuels. So some of you may be asking yourselves, how is this type of energy and resource easily renewed? Well, Aaron will give you the scoop on this one.
The algae is made in the algae farms and the raceways. Also, algae is naturally found and made all around the world. There are more than 7,000 different species of algae. Most live in the oceans, but they also live in freshwater and even on land. There's no shortage of algae because there's more growing in the natural world each day.
What is the cost of using this type of energy resource?
I'm glad you asked, Aaron. According to a 2010 research study by the Lawrence Berkeley National Laboratory, producing fuel from algae growing in ponds at scale would cost between $240 and $332. Also, the production cost is high because of the energy required to circulate gases and other materials inside the photobioreactors where the algae grow. It also takes energy to dry out to the biomass, and Solix uses far less water than other companies. Algae costs more per unit mass than other second-generation biofuel crops due to the high capital and operating costs, but are claimed to yield between 10 and 100 times more fuel per unit area. So Aaron, what are the positive aspects of using this resource or type of energy?
Well, I'm glad you asked, Katie. Algae could potentially produce up to 60 times more oil per acre than land-based plants. Algae needs carbon dioxide to grow, and that's good for the environment since it takes CO2 out of the atmosphere, making it nearly carbon neutral source. Among algal fuels' attractive characteristics are that they can be grown with minimal impact on freshwater resources, can be produced using saline and wastewater, have a high flash point, and are biodegradable and relatively harmless to the environment if spilled.
So Katie, I was wondering, what are the negative aspects of using this resource or type of energy?
Unfortunately, algae production consumes more energy, has higher greenhouse gas emissions, and uses more water than other biofuel sources like corn, switchgrass, and canola. Growing algae in open ponds is akin to producing them in a shallow swimming pool, so all the nutrients, like nitrogen and phosphorus, needed to keep them alive and boost their production come from outside sources. The fertilizer that is used has an environmental impact because it's often made from petroleum feedstocks. Carbon dioxide also contributes to the algae's environmental footprint. Algae use sunlight and water to convert carbon dioxide into materials that can be easily converted into fuel. But that CO2 has to come from somewhere. So Aaron, I also have another question for you. What is the science behind this resource and type of energy? And I know this is a very important question.
Well, first of all, we should talk about how the energy is gathered. So the oil is made from the cell structure of algae. It is done by using solvents or sound waves. After the oil is extracted, processed at an integrated biorefinery, or in the future, at a traditional oil refinery, the oil that is extracted from the algae has the raw materials to make fuel for cars, trucks, trains, and planes. Scientists are testing different algae under many different conditions to find the best strains and the most efficient farming practices. So, how is the energy stored for later use? The type of energy does not need to be stored much. But when it is, it can be stored in the raceways in algae farms. Algae is so easily made that it's easy not to have to store it in any place. It can be taken from anywhere.
Well, Aaron, what about the waste that this algae energy produces?
So the green waste left over from the algae oil extraction can be used to produce butanol. For reasons of economy, some experts think that the algae farming for biofuels will have to be done as part of cogeneration, where it can make use of the waste heat and help soak up pollution. So many people have asked, currently, what is keeping this form of energy from widespread use? Well, I will tell you. It costs a lot of money to start the production of biofuel from algae, and right now the United States has invested vast amounts of money into it, but more money needs to be invested in order for it to be a successful form of energy for our country. Even though this production might require money to start it up, once we have it going, it will save money and the environment in the long term.
So now we are sadly on to our last question for today.
So Katie, when is the energy or resource expected to be easily accessible to the general public?
Once again, another great question by Aaron Gillen. This type of energy will be accessible to the general public as soon as the production sites are stable, and there's enough of them to be able to sustain the United States and the need for energy.
So now, listening to everything that we've said today, both myself and Aaron Wilma Gillen, this important PSA is coming to a close. Aaron and I hope that you all realize how important it is to shift from the non-renewable sources to renewable alternatives. Though it may be hard to shift to a totally new way to obtain energy, algal energy, for example, the transition is necessary in order to make our world happy and healthy for years everlasting. Yay!